Okay, we got one more video to do for our statistics unit, and that's probability. So let's get straight into it. So these examples are screenshotted straight out of the EOC book and from practice tests. So yeah, seems like a good idea. So example 1, Farmer Jacob owns so many sheep that he has 5 assistant shepherds. He wants to check on the composition of his flock, so he selects 40 sheep at random to see what they look like. Striped sheep are the most valuable. The results of this survey are below. So we have types of sheep. We have white, black, striped, and speckled. And then we have the number of sheep. So there's 15 white, 12 black, 7 striped, and 6 speckled. If one sheep is chosen at random, what is the probability that it is striped? If Farmer Jacob has 750 sheep in total, how many of his sheep will probably be striped? So we're looking at kind of percentages here. You can think of it like that. So of the sample here, remember there are 40 if you add up all of these, right? So let me just double check that. 15 plus 12 is 27. 27 plus 7 is 34. 34 plus 6 is 40. Yeah, it did say he selected 40, but I just want to make sure. So we've got 40 sheep. So 7 out of the 40 are striped. This gives us a probability. 7 out of the 40 are striped. This is also a percentage, but we're going to go ahead. I'm going to get my calculator. We're going to type this in. 7 divided by 40 is, of course, 7 out of 40, which is 0.175. So 7 divided by 40 is 0.175. And if you move the decimal place 2 places over, this is the same thing as 17.5%. So 17.5% of the sheep are striped. But to answer the question, technically, when it says what's the probability that it is striped, the probability it is striped is technically just a 0.17. Probability is left as a decimal, but if it ever asks to put it into a percentage, you just got to move that decimal place 2 places to the right, or multiply it by 100, same thing. Now, to answer the next question is if Farmer Jacob has 750 sheep in total, how many of his sheep will be striped? Well, if I know that 17.5% of the sheep are striped, well, what is 17.5% of 750? Now, to calculate this, we're just going to take my probability, which is 0.175, and we're going to multiply it with 750. So this will give me the number of sheep, or the 17.5% of 750 that I'm looking for. So go back to my calculator, discard this. All right, so 0.175 times 750, and we have 131.25. We're going to round that to a whole number, which is 131. So we're going to say if you have 750 sheep, 131 of them are probably striped if, of course, it's the same probability, right? That 1.75 still holds true, which it should. So hopefully that made a little bit of sense. I really don't know how to explain it, which kind of sucks as someone who's supposed to be good at explaining things. But yeah, if you want to find probability, you're going to take the number. Again, there's a good way of saying this, and there's a bad way of saying this. The number specified, right, or specific, the thing you're looking for, number specific, which was 7 striped, divided by the number in total. You're always going to do that for your probability. The number that you're asked for divided by the number in total. So that's what we did. We took the 7 that we were asked for, because that's what we were asked for striped, and then we divided by the total, which was 40, and that gave us the probability. Now, if you ever want to use that probability to represent a larger population, you can take that probability and multiply it by your population, and that will give you that estimated number that we looked for just a second ago when we took the 0.175 and we multiplied it with the 750. All right, look at example 2. Christy Joe is on the prom planning panel, PPP. She does a random survey of 30 female classmates to find out their plans for prom. The results are shown below. So we have 5 girls, 5 females have a date. 13 females hope to have a date. 3 are attending without a date, and 9 are not going at all. So what is the probability that a female student selected at random is planning to attend? If there are 340 female students eligible to go to prom, how many should Christy Joe expect to attend based on this survey? So let's answer the first question. What's the probability that a female selected at random is planning to attend? So how many did she survey? So we've got 30 in total. So remember, we're looking at the number specific that we're asked for and dividing it by the number in total. This will get me my probability. So my number in total, I know, is 30. So I'm going to be dividing this by 30. But what am I specifically looking for? I'm looking for the ones who are planning to attend. Now, that's kind of tricky because we don't have a planning to attend column. But if they have a date, then they're planning to attend. If they hope to have a date, then they're planning to attend. And if they're attending without a date, then they're planning to attend. So technically, it's kind of tricky, but we're going to add these all up because 5 plus 13 plus 3, that's all the number of girls who plan to attend, which I believe is 21. 5 plus 13 plus 3 is 21. So 21 out of the 30 girls surveyed plan to attend, while the other 9 are not planning on attending. But we'll calculate this in our calculator. We'll get a solid number. That'll be our probability. So 21 divided by 30 is 0.7. So our probability here is 0.7. Or, again, if you imagine that decimal place being moved, that's 70% of the girls are planning to attend prom. But that's not really relevant. The answer to the question, probability, is technically just 0.7. But now, there's 340 female students, right? If 70%, probability 0.7, plan to attend the prom, how many should we expect to actually go? So remember, to answer this question, we're going to take our probability, we're going to multiply it by our population. So that's going to be 0.7 times the population, which is 340, and we'll get an estimated value. So 0.7 divided by, or 0.7 times 340. So 0.7 times 340 is 238. 238 girls we can expect to attend prom if that survey holds true, of course. So anyway, yeah, it's very similar to example 1. Okay. Last example, a survey asked 410 students. So keep in mind, that's helpful numbers. This is the total number of students. Total number of students. Whether they would eat food served in the cafeteria. The results are recorded in the table shown below. So you could see that, ninth graders, 67% of the ninth graders say yes, they eat cafeteria food, and 33 say no. 63 10th graders say they will, 47 10th graders say no, and so on. So you can see the table. Let's answer the question. What is the probability that a student will not eat food served in the school cafeteria given that the student is in 10th grade? So this is kind of tricky because, yes, there are 410 students in total, but it's telling us, what if we chose a 10th grade student? And it's specifically just a 10th grade student. Then all the other bits of information here are irrelevant. So we're only focusing our attention on the 10th grade. So the same applies, though. The number specific divided by the number total. But the number total is not 410 because I'm not looking at all the grade levels. I'm only looking at 10th graders. So what's the total number of 10th graders? Well, 63 plus 47 is 110, I think. Yeah, so there are 110 10th graders in total. Now, number specific, I'm looking for the ones that will not eat cafeteria food. So that is 47 of the 10th graders will not eat cafeteria food. So 47 divided by 110. So you do have to be kind of careful. Make sure you read that question carefully. So 47 divided by 110 is 0.42, we'll just say 0.43. So the answer to this question, it says nearest hundredth, which, yeah, is 0.43. So 0.43 is our answer. Okay, and remember how we got that was we got the number of specific 10th graders who did not want to eat cafeteria food, which was 47, and divided by the total number of 10th graders because the question only asked us about the 10th graders, and there's only 110 10th graders. It does not say anything. We're not selecting an 11th grader, 12th grader, or 9th grader, only selecting a 10th grader. There's 110 of those in total, and out of those 110, 47 of them would not eat the cafeteria food, so that's our probability, which came up to 0.43. That's going to cover it for this. Good luck on your homework. If you have anything else, let me know. I will see you guys after the quiz.